Welcome to lesson number 6. We're going to be looking at graphing the primary trig ratios and graphing primary trig functions. In this lesson, you're going to be introduced to two new terms, and these terms will be new if you haven't taken Physics 11. But we're going to be looking at the terms period and amplitude as they relate to waves. So if I'm defining the period event, so there's a definition here. I don't really like this one, but a periodic function is a function whose graph repeats regularly over some interval of the domain. So I like that section actually, but this section, the length of this interval is called the period of the function. So the length of a certain interval. Another way we could put it is a period is the time interval. So if we're thinking about the x-axis as time, I guess this is where there could be a little confusion because the x-axis doesn't always refer to time, and we'll look at an example where it doesn't. But if the x-interval did refer to time, then it's the time between two repeating events. And so if I'm looking at these graphs, my period would be the time between, or the units between two repeating events. And so I have my function starting here, and then it goes up into the positive, down to the negative, then it goes back up to the positive. And so the point though where it repeats is at 8. So from 0 to 8, I would say that's one event, and then this event is repeated again from 8 to 16. So that being said, my period would be from here to here. This would be my period. Also referred to as t. So we could say that period is equal to t. Another new definition you're going to have is the amplitude. If we have a periodic function like this, the amplitude is defined as half the distance between the maximum and minimum values of the function. So if this is a maximum value here, and this is my minimum value, the period is the distance between the top and halfway, or the bottom and halfway. So my amplitude here would be 10, from 10 to 0, or negative 10 to 0, but 10 units. So my period here is equal to 8 units. My amplitude, or A, is equal to 10. Another way we can look at this is the difference between 10 and negative 10 divided by 2, which should just be 20 divided by 2, or again, as we already stated, 10 units. It's nice having this formula because sometimes we'll have points that are difficult to read, like down here. So if I look at the point where I have a repeating event, so if I start here at the 0, at x equals 0, and look to the point where I have this curve being repeated. So if I go up the curve, back down, up the curve, back down, the point that's repeated is from here to here, from 0 to 6. So I would have a period of 6 units. My amplitude would be equal to my positive 6, subtract my y value, which is at negative 2, divided by 2, or 8 divided by 2, and that's 4 units. The last example here is if I'm starting at x equals 0 and I'm down here at positive 2, so 0 and 2, I go sideways, I go up, over, down, sideways, up, over, down. So what's being repeated is this section here. So my period would be from 0 to 10. So my period is 10 units. And the amplitude is going to be where my maximum and my minimum point is, the difference between the max and min divided by 2. So 6 over 2 is 4, over 2 is 2 units. Alright, so 3 different examples of amplitude and period. Next, we're going to be getting into the graphing of the functions. So when we're graphing these primary trig ratios or primary trig functions, so sine, cosine, and tan, we're going to be looking at y equals sine x, and then the graphs of cosine x and y equals tan x will be in the assignments. So, graphing y equals sine x where x is in degrees. So complete the following table of values for domain x is greater than or equal to 0 degrees but less than or equal to 360 degrees. Give your answer to 2 decimal places where necessary. Alright, all we need to do here is define what sine is equal to at all these points. So if I have my calculator, I want it to be in degrees. So I'm in degrees, which is good. And we're just going to type all these. So sine 0 is just going to be 0 degree or 0 for my y value. Sine 30, I get 0.5. Sine 60 is 0.866, or we'll say 0.87. Sine 90, well, that's one that you can remember, but that's 1. Sine 120 is 0.87 again. Sine 150 is 0.5. And remember, if we're going into the second quadrant with these, then they're going to have the same reference angles as 30 and 60 degrees as they rotate counterclockwise. And 180 degrees is at the same point as 0, so that's just going to be 0. 210 degrees, I'm going down to the third quadrant, but that would be negative 0.5. And we can also just sine 210, negative 0.5. 240 is going to have the same reference angle as 60 degrees, so that's going to be negative 0.87, but because it's negative because it's in the third quadrant. 270, same position as 90 degrees, but between the third and fourth quadrants would make it negative. And then 300 degrees, again in the fourth quadrant now, it's going to be negative 0.87. 330 degrees, same reference angle as 150. Fourth quadrant would make it negative 0.5. And 360 degrees, of course, will be 0. Alright, so these are the points that are going to correspond to the graph that I need to make below here. So at 0 and 0, I'm going to be at 0. And so we're taking all these points, my x-axis being 0 degrees, 30 degrees, 60 degrees, and so I'll just follow it as it is here. Excuse me. But my y-axis corresponds to the points that I got from either my unit circle or that you've calculated. So at 30 degrees, so I got 90 degrees here, and at 90 degrees I was at 1, 180 degrees, I'm at 0, 360 degrees, I'm at 0, at 270 degrees, I'm at negative 1, 540 would be 0, 450 would be positive 1. Right, so you're kind of seeing the trend here. If I were to go into my negative quadrants, negative 90 would be at negative 1, 180 would be at 0, negative 270 would be at positive 1, and 360 would be at 0. If I look at these other points, like so now instead of just drawing this curve, I should make sure that 30 degrees and the points in between 90 and 180 are going to be along this line. And so if I was looking at for 30 degrees, 45 would be here, so 30 would be around here. I'm at 0.5. So 0.5 is around here. Alright, so if I look at these points, 30 degrees would be here, 60 would be up here at 0.87. We're going to have a nice curve that's formed. Alright, so all these other points in between are going to fall in between this line. But we're going to have a nice sine curve on my graph. Alright, isn't that awesome? So if you've taken physics and you've looking at you've studied waves, physics 11, you don't get too deep into the trig functions and graphing them, and this is something you do a little bit more in physics 12. But how would we actually plot this on a calculator? So if you use standard window settings, it's going to be very difficult to see. So we have to change our window settings. So on your calculator, we want to input these window settings. And so I'm just going to put my calculator back to standard window settings. If I were to graph this on a standard calculator, the function that I have is what? Is sine x. I'm just going to clear that as well because we don't do that step until step D. But we want to change these window settings. So in my x-axis, I want to have a minimum value of negative 360, a maximum value of 540, and a scale that goes up by 30 degrees each time. Another thing, make sure your calculator is in degree mode, so go to the mode and switch to degrees. In my y-min, I want to have a minimum value of negative 1.2. I want to have a max of 1.2 and then a scale of 0.2. And my window is going to look something like this, but I need to graph my function. So that's the function y equals sine x. So sine x graph. And there's our sinusoidal curve that forms, or our sine curve that forms. And so if you look at this, this is what we would call a periodic function, a function that has a repeating event at a certain interval. And you can see it right here. All right, so let's look at example 2. State the following for the function y equals sine x, where x is defined on the set of real numbers and is expressed in degrees. So first, my domain. Well, my domain, if I look at this, my x, these are elements of real numbers. Even though it's in degrees, they're real numbers still. So x is an element of real numbers. The amplitude. When we're looking at the amplitude here, remember that that's the difference between the maximum and the minimum points, right? So if I were to calculate my amplitude, 1 minus negative 1 divided by 2 is 2 divided by 2, or is equal to 1. That's my amplitude of 1. And we can see it here. We know that from 0 to 1, it goes up by 1, right? So this is the halfway point. The halfway point is 1 unit. X-intercepts. So where does this cross my x-intercept? Well, I have a point crossing at 0 degrees. I have a crossing at 180 degrees. I have it crossing at 360 degrees. So every 180 degrees it'll cross my x-intercept again. At 540 degrees it'll cross, and so on. And so my x-intercept is just 0 degrees, 180 degrees, 360 degrees. The range, well, we know what the amplitude is, right? It went up by 1 and it goes down 1 unit. So my y value has to be greater than or equal to negative 1, but less than or equal to positive 1, and such that y is an element of real numbers. The period, well, if I look at the period, it's easier on the graph here, but look for that repeating event. So it goes from 0 to 180 to 360. So 0 to 360 is the repeating event. So my period, we would say, is 360 degrees. And the y-intercept, where's the point it crosses the y-axis? That is also at 0. And lastly, we'll look at class example number 3. So a student was asked to reproduce the graph in exploration in radian mode. Write down the graphing calculator window format the student should use. So if I look at my window mode, and if I were to switch this to radians, negative 360 degrees would correspond to negative 2 pi. Negative 540, that's another rotation, would be 3 pi. And if I have a, remember x value, or the x-axis is in degrees, so at 30 degrees, that would correspond to pi over 6. And we could, because we, pi over 6. And because our y-axis was just a unit of 1 radian, then, or sorry, of 1 units, then we can just leave our window settings like this. But my x windows would be negative 2 pi, 3 pi, and pi over 6. And the y window would remain the same as in degrees. And in order to graph this, it would have to be in radians, and then we graph, and we actually get the exact same graph, y equals sine x.